let's turn to a discussion of hops, which is one of the key ingredients for flavor and aroma in beer. Here is an old botanical cartoon or old botanical drawing of the hop plant. What I want to draw your attention to is really these cones of the hop, which are very distinctive. And you can see a cutaway version, a cutaway photograph here. The key thing is to note is that each of these bracts houses a lupulin gland, which secretes this lupulin, which is a complicated mixture of compounds, but is largely composed of so-called hop acids. Hop cones themselves can be anywhere between 15 and 20% hop acids, and we'll describe exactly what those are. There's a smaller component, although very important component, of essential oils. These are volatiles. Remember, they're going to have very strong aromas. Also, it should be clear that there are dozens of hop varieties, and I'm not even going to try to enumerate what those are and what the characteristics of those are. Suffice it to say that they really vary in terms of the different composition of hop acids and essential oils. The so-called noble hops, for which there are very poor definitions, mostly refers to the more aromatic varieties, which are probably going to be higher, perhaps in essential oils. Right now, it is worth mentioning that bitter beers are very, very fashionable. So beers that are have high concentrations of those hop acids that give rise to bitter flavor are currently in vogue, and we'll talk about what that means right now, in fact. So, what are these acids? Well, there are two kinds of hop acid. And if you're an organic chemist, you're going to look at this and say, well, I don't see an acid group. And let's leave that aside for now. These are referred to as the hop acids in any case. Here are the alpha acids and the beta acids. So in case you don't know, this is the Greek letter for alpha. And this is the Greek letter for beta. There are two categories that we can place these alpha and beta in happily. One is the bittering hops, and one might be higher in more aromatic resins, or more contributor to the aromatic characteristic of hops. So, first of all, the alpha acids here, what I've drawn to start with is humulone. That's this guy here. In red, what I've tried to give you a sense of is that these different alpha acids are all very, very similar. Where they differ is here in this this is in organic chemistry terms, they'll vary in the composition of this functional group. There's a wide variety of alpha acids, and I'm not going to describe them all. I've given you a couple of names here. But instead, what I want to point out is that, first of all, let's notice that the alpha acids are very similar to the beta acids, except for the existence of this extra arm, which let's leave aside for the time being. But what's key for hops, especially the alpha acids, is that they give rise to an enhanced bitterness, which is so important in so many modern beers. How do they do this? Through the chemical process of isomerization at high temperature. So this form of the molecule interconverts to another form, which is called the isomerized form. It's another isomer. And this delta here, this triangle, indicates that we're applying heat. All I really want to make clear is that this is bitter. This isomer of humulone is bitter. This isomer is not. And so this heating process is critically important to the development of the bitter flavor of the alpha acids. The other interesting thing to know is to pay attention to is that this is a light-sensitive compound. And if it's exposed to light, this is why we put beer in brown bottles, right? To protect them from exposure to light. Oops, I'm now misspelling bottle, excuse me. Protect the hops from exposure to sunlight, which can also be referred to as sunstruck. Although I think it's more common to refer to these as skunky. Why are they referred to as skunky? Well, the breakdown products interact with thiols. These are sulfur-containing compounds that can form unpleasant odor compounds when they react with these alpha acids. So So we get bitterness is important, but we also have to remember that the alpha acids can give rise to some unfavorable characteristics as well. Although, of course, there's plenty of beer drinkers out there who will say that the bitterness might be a undesirable quality as well, although they are not in the majority amongst beer aficionados at this time. Turning now briefly to the beta acids, I mentioned here's lupulone is the one that I've drawn, and I'll remind you here that the only thing that I'm trying to draw your attention to the idea that lupulone, there are other beta acids in hops as well that are very closely related to lupulone, except that they vary only in the composition of this functional group. These do not isomerize, and we won't go into the chemistry of that, but it's an interesting story. They do not isomerize. They also are known to have a higher volatility, but they're also very sensitive to temperature, and they'll degrade and precipitate, and will lose the aromas and flavors that they can contribute. So this allows us to bring up an interesting point, which is that frequently hops can be added during kegging after the fermentation and after the mash-in. This is called dry hopping. And we can add these. We can add them at different stages. Suffice it to say that they're added at a stage that will prevent them from being destroyed by elevated temperatures. So dry hopping. But in addition to the hops, let's just point out that there are other contributors to aroma and flavor, and mostly these are the essential oils. I've just drawn one for you, which is called humulene, not to be confused with humulone, but contributes significantly to both flavor and aroma derived from hops. Let's also point out, however, that the addition of hops after boiling is important for the maintenance of these flavors because they're more volatile than other compounds, they're going to be driven off at steps that involve high temperatures. Okay, I want to talk another minute about bittering because it's so important in modern beers. There are metrics of exactly how bitter a beer might be. There are a few different scales. We'll focus only on the international bittering units. This seems to be the most favored scale at the moment. What the bittering units measure is the concentration of these isomerized, remember, bitter forms of the alpha acids. As I said, the beta acids don't really give us much in the way of bitter flavor. And so when we're trying to quantify bitterness, then we're going to measure the concentration of these alpha acids, specifically their isomerized components. Remember that isomerization driven by the temperature change. So let's look at some different characteristics. Again, different beers. This is not an exhaustive list, but if we look at an American lager or a blonde beer, we're going to see a very low bitterness score, whereas the barley wines are going to be very bitter, high bitterness, right? Now, wheat beers, 15 to 20, pale ales, 20 to 40. India pale ales, remember I said these are known for their intense hop flavor, anywhere from 40 to 60 or even greater. Especially in the last decade, I'm going to assert that the intensification of India Pale Ale flavor has gone rampant. Okay, now, so we can make a measurement of the bitterness using this IBU scale, but let me just insert a couple of skeptical comments here. Most brewers use a formula to calculate IBUs based on the hop recipe. How much of what kind of hop they're adding. Now, that's only useful or only meaningful if the hops that we're using are very reproducible. And so oftentimes what you'll see, this will be very difficult to compute if you happen to be using your own hops. But if you're buying hops from a vendor that uses these pellets or plugs, I don't have a picture to show, but you can find them online, then you're a little bit more standardized. But in any case, you're making some assumptions. So there's my science term for this slide. We're making some assumptions when we just accept what the manufacturer tells us and make a calculation. Actual measurement of the IBUs requires some chemistry. It requires solvent extraction. I'm going to remind you that I mentioned solvent extraction when I talked about the flavors that can be extracted from oak barrels by ethanol. Well, likewise, you can extract these organic molecules from the hops using various kinds of solvent extraction. And then we do various kinds of spectroscopic analysis of those purified alpha acids. So we basically have to isolate the alpha acids and use some tricks to find out exactly how much of each kind of alpha acid there might be. What's spectroscopy? Well, it's just the interaction of light with matter. And I won't go any deeper into it than that at this time. The other important point I want to make is that you'll see, you can find beers with IBU ratings that are more than 100. The truth, however, seems to be that most people's palate can't distinguish anything greater than that. And so, yes, you can add more and more and more alpha acids, but it doesn't affect, it at some point ceases to affect the flavor in a way that depends on the individual, right? Some individuals are more sensitive than others. So you be skeptical when you see the IBU score. Ask them how they computed it. Was it measured? Was it calculated? Is it greater than 100? I challenge you to go to your neighborhood brewery and find out what the IBUs of all of their different beers are and tell me what you think. Can you distinguish between these different ratings on this scale?